Don't you think Q1 is good enough? Your 25% people are in 48 category, which is sort of good. The lesser the HT is, the better it is. We have taken a target of, we have
Yeah.
taken, okay.
But so here we can see that so for Q1 there is between 10 to 48.75, so the variance is quite low. Whereas when we see Q4, so it is between 489 to 884.
Yeah,
So
yeah.
its variance is really high.
So absolutely correct. Agree with you.
Correct.
So
Yeah.
which means my 75%, my last quartile is from 489 to 884. So the last quartile, my bottom quartile people, my 25% of the people is above 490 to 884. And if I consider median as 287 here, okay, which means that my 50% of the population is less than 287.5, which is between, which means 0 to 287.5, and 50% is 287 to 884. Okay, so which means there's a huge variance in Q3 and Q4 both that I need to work on. Okay, so that's what box plot tells me, the amount of varies. So in quartiles, we just look at the numbers.
Where is Q4 mentioned?
Okay, Q4 is not mentioned anywhere because this is my Q3. Okay.
Yeah.
This is my Q4. This is the outliers that you can see.
So if we
But
just
yeah, I was just
discuss,
about to say that.
Sorry, I'm not able to hear.
But
There's some distance. Yeah. Can you repeat?
yeah, I was saying that it's like an outlier, right? So, should we take an outlier situation into our understanding process to make a call about that this is the quartile that needs to be looked into?
Okay, two things here. In order, so Minitab doesn't know here that whether HT is higher the better. Okay, it doesn't, lower the better. It doesn't know it. It just shows me a outliers in the initial phase and in the later stage also. Okay, but I know the lower the better it is. So although there is a lot of spread here, you can see. Okay, which is good for me. Probably if these people are doing really well, they are following all the best practices, I will try to shift the quartile 2 to quartile 1 also. I would say that if this 25% of the population, so out of 62, if I divide 62 divided by 4, which is around 15 people, average is, median is 48.75. The next 16 to 30 average is 287.5. So probably I need to work on this piece as well if this goes good. Now question to this, why this shows a outlier? Because you see up till Q3, quartile 3, it was 489.75. But my quartile 4, my last value, my extreme value is 884. This is my Q4. So there's a humongous variance that you have observed from Q3 to Q4. Therefore, this is for sure that this particular Q4 is doing exceptionally insignificant that I'll have to work upon. This quartile requires a lot of focus and attention because they are significantly performing less better than others. So this is something which I'll be working on.
But don't we also have to see the volume that is contributing to that, because as we understand it's an outlier situation and the rest of them are, we can see that they have a good volume. But if this one is not much of volume, maybe couple of handful of people are contributing to that outlying value, then we shouldn't we take a call accordingly? Just for my understanding, right?
So Remy, volume is the same in all the quartiles. It is just the number is different. So if you have 20 data
Okay.
points, Q1 also has 5, Q2 also has 5. The number of occurrences remains the same. It is just their median is different. That's why it is
Okay.
quartile. It has divided the data equally into 4 different parts. This is not the volume.
Okay.
This is the performance. This is the performance.
Okay.
So here also the volume is 25%. Here the volume is 25%. The volume remains the same, 25, 25, 25, 25. It is the performance which has a lot of variance. So I am concerned about the variance performance, wherein I see that the last 25% has a lot many variance, okay, where the range starts from 489 till 884.
489 to 884. Yeah.
So ये भी 25% है, ये भी 25% है, ये भी 25% है, और ये भी
Okay.
25%.
Got
Okay.
it. Got
Got
it.
it?
Yep.
The last thing which is called IQR. You can see IQR. Okay. IQR is a measure of dispersion. Likewise, we calculate standard deviation apart from variance. So IQR is Q3 minus Q1. If you deduct Q3 minus Q1, you will get IQR. So that is the measure of variance for median. Okay, so the lesser IQR it is, the better it is for us. So that's what is box plot when you have only one subgroup wherein you are comparing it for entire HT. You can look at box plot group wise also. Let's do that. So I go to graph, I go to box plot. I want to do it with groups. Okay, so where it means I want to do it HT wise team leader. Now I have 3 different team leaders. I have 3 different box plot being prepared. Now if I ask you a question, which team leader has less variance?
Paul Smith.
Please explain so that everybody can be on the same page.
So for Paul Smith,
let me help you. Let me help with the number so that everybody can see. Just a second, Anand. Yes, please continue.
Okay. So for Paul Smith, in the Q1 we have 37.5. The median is 171, and my highest point is 723.
Yeah.
Can we move to Mary and Andy as well, just to have
Yeah.
the median? The IQR is 330 for Paul, 432 for Mary, and for Andy. So Simar, my understanding here is obviously the median is low for Paul Smith, plus the IQR is the lowest.
Yeah. So IQR is a deciding factor which tells me that which has less variance. So 623 is for Andy, 432 here, and 367 here. Apart from IQR, you see that Andy Stewart. Okay, so earlier we looked at the entire HT for all the samples that we have. Now we are looking at team leader wise. So want to look at which team leader is contributing to more variance so that we can work on it. Here you see the extreme values here, which has come till 884. Okay. However, Paul maximum value was till 723 and Mary maximum value was 787. So of course, for sure, Paul Smith is performing better than Mary and Andy. And if I sort it, it is Andy which needs to be focused more than Mary and Paul. So that's the box plot. You can prepare it by categories also. Okay.
But Simar, just a question.
Yeah.
We are considering AHT here. Obviously, as you said, that Minitab won't recognize whether it's lower the better, higher the better. If this was sales, though the
Yeah,
variance for Andy is pretty high
yeah.
in this scenario, then in
Mhm.
that case, we would concentrate on Paul Smith, right?
So let's assume for a while that these HT numbers were in crores, and this is not HT, this is a revenue generated by these three business managers, right?
Mhm.
And now, so let's see, these are different managers. In box plot, I'm not concerned about the performance. I'm concerned about the variance.
Right.
Okay. Even though Andy is doing really well, but I would like to understand that is there any best practices that he's following? Therefore, there is a lot of spread between. Though he has reached to the peak, right? His team has his last 25% of the people have done really well. But if I look at the variance, it starts from 56. So they have done 56 lakhs till 884 lakhs. Okay. Here they have done 38 lakhs till 787 lakhs. So I would like to question this quartile to see that what best they are doing. But but when it comes to the variance, it has huge variance.
Yeah.
So my purpose of doing box plot is not to check the performance. For that, I can do the one-way NOVA as well. Okay,
Yeah.
to look the significant difference. This is typically like your test of equal variance, but in a box plot sort of way, wherein I am looking at the different quartiles. Test of equal variance does not tell me the different quartiles. It just tells me the overall, but for quartile wise, it tells me the box plot. Okay.
Perfect.
So just
So,
remember box plot. Yeah.
sorry, yeah. So, Simrit, in this one, if it's a sales revenue figure, then here we need to focus as to why only a portion of his team members are doing really well with whatever best practices they are doing, and rest of
Yeah.
them are not able to actually follow that. So that is something we have to then see and try to improve their performance. So that can be one of the
Right.
improvement areas we can think of.
Right. So it could be a possibility that I need to practice Andy's best practices also with Mary and Paul, even though there is a lot of variance. So the question here is we need to study what Andy's team is doing. Although it shows that their sales figure has reached to the peak, but we also are concerned about this quartile as well, why there is a lot of variance here. 25%, why there's a lot of variance. Okay. So either ways, we will have to get into it to identify it. But looking at the variance, we find that Paul is doing really well. Okay.
Similar. So here, when I observe this, so let's say Paul Smith. So as the as the whisker on the top is quite high, so that means can we assume that okay? So that means that there is an outlier. There is a very outlier which is at the very
Mm-hmm.
end,
Mm-hmm.
due to which it is showing this much variation. But when we compare it to the interquartile range, so
Yeah.
the interquartile range is the tightest here,
Yeah.
and which shows that on an average, like the average people in his team, in the middle of the bell curve, let's say, so they are actually working quite consistently.
Yeah.
Whereas when
Yeah.
we look at Andy Stewart,
Yeah.
the center of the bell curve is quite spread out.
Exactly. It's all about spread that we are looking at in the box plot.
Okay, yeah.
Absolutely. So as mentioned earlier, IQR is a deciding factor here, which is the first step that I'll be looking at, and then I'll make conclusions. So there could be a possibility that even though after looking the Q3, if I consider Andy here, and if I see that this particular peak is quite possible reaching 800, okay, I might need to change the target also next time. Okay. And in that case, you would see a different sort of a box plot, because in that case, the numbers, there will be a shift in the median for other people as well in the near future. So let's say this is before the project, and after the project is completed, you might see that the variance would be kind of good in Andy as well in the later run also. So this just gives you a representation which of these three different categories has more variance. Is it clear to all of you?
Yes, Emma.
Yeah.
Great. So with this, we have completed the analyze phase with all the topics that we were supposed to cover. And by the end of the analyze phase, we all should be able to conclude what my critical axes are and what are the root causes which have derived from each of the significant causes that we had. So just to take you back, during the analyze phase, let's say you identified 30 causes, and on 30 causes you prioritized during the prioritization exercise, and you identified that there are 12 which are high in impact. On all 12, you have done the hypothesis testing. On all 12 which were significant, which were high in impact, you did the hypothesis testing. And so 30 from 15. So these were from brainstorming. This were high impact. And final X, you got 10 because you did the hypothesis on all 15, and out of 5, there were 5 were null and 10 were alternate. Okay. And you've done the analysis on these 10 X's also by doing the root cause analysis. And you've concluded that these are the 10 final X's, or you can say as confirmed X's, which I will have to work on to improve my project Y. Okay. So with this in mind, I will get into the improve phase. So I am just sharing my improve slides.